Today we're going to be talking about the distance formula, and our objective for today is that we will be able to apply the distance formula to find the length of line segments when given the coordinates of the endpoints. So if we were looking at the length of a segment versus the distance between 2 points, we would basically be talking about the same thing. They really just mean the same thing. So if it is 60 units for this segment, then the distance between A and B would also be 60 units. Now let's look at different ways we can find the length of a segment or the distance between 2 points. Think back to the Pythagorean Theorem. This is for finding the lengths of the sides of a right triangle. Remember that C is the hypotenuse because it is across from the right angle, and A and B are our legs. The Pythagorean theorem says that C squared will equal A squared plus B squared. And we can use that to help us out when finding distance. So let's look at example number 1. Finding distance on a coordinate plane. It asks us to find the length of the segment with these endpoints. P is at 0, 2, and R is at negative 4, 5. What's another way we could ask this question? This question could also say, find the distance between the points P and R. So based on these coordinates, I know I'm going to need a little bit on the negative for the x values and only positive y values. So I'm going to put my y-axis in the middle, and I can put my x-axis down here. So let's graph these. P is at 0, 2, and R is at negative 4, 5. And we want to know the distance between them. Now, most people would think we could just count these boxes, but that's not really how it works because one unit is the side of a box, not the diagonal. What we can do, though, is look at how far they are apart vertically, which is 3, and how far apart they are horizontally, which is 4, and now we've created a right triangle, and we can use the Pythagorean theorem. So if C is our distance, we know that C squared equals 3 squared plus 4 squared. So let's simplify and solve. C squared would have to equal 3 squared is 9 plus 4 squared, which is 16. 9 and 16 is 25. And remember to undo our squared, we're going to square root both sides. So we get that C is 5, or the distance is 5 units. Now sometimes our solving doesn't work out as nicely, or the numbers are just much bigger and we don't want to have to count all the spaces on our graph paper, so we have the distance formula. The distance formula is the distance equals the square root. So we have a square root in the formula, just like we had a square root when we were solving. x2 minus x1, that amount squared. Let's look. Our x distance, the x from where r was to where p is, that's your x2 minus x1 part, and we squared that number. Plus, we had a plus sign right there, y2 minus y1 squared. This is dealing with our vertical side of our triangle. Another way that this can be written is that d equals the square root of x minus h squared plus y minus k squared, where x and y is one point and hk is the other point. When you get into class, we're going to look at the formula sheet and see why this formula might be a little more helpful than the first one. So let's try a problem where we're going to have to use the formula instead of the graph paper. So find the distance between the points M, which is at 1, 2, and N, which is 5, 4. What's another way we could ask this? Find the length of segment MN. So I'm going to label my first point as X and Y. I'm going to label my second point as H and K. And I'm going to use the formula where D equals the square root of X minus H squared plus Y minus K squared. Let's fill in our numbers. We're trying to find the distance, so that equals the square root of X is 1 minus H, which is 5, close your parentheses, squared, plus Y is 2 minus 4, close your parentheses, squared. So we think back to order of operations. We need to simplify the parentheses first. We get the square root of 1 minus 5 is negative 4. Make sure when you are dealing with this formula, you keep the parentheses around the simplified part. It'll save a lot of trouble when you're putting things in your calculator. Plus 2 minus 4 is negative 2 squared. Negative 4 squared will give us 16. Plus negative 2 squared will give us 4. So we get that our distance equals the square root of 20. Now 20 is not a perfect square, so we're not going to have a nice whole number answer for this problem. So what we need to do is simplify the square root of 20. We want to find the biggest perfect square that 20 is divisible by. So let's review some of the perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. I'm going to stop there with my squares because 25 is bigger than 20, so that's not going to be helpful. Is 20 divisible by 16? No. Is 20 divisible by 9? No. Is 20 divisible by 4? Yes, it is. 20 is equal to 4 times 5. So I'm going to break this up into the square root of 4 times the square root of 5. Then we're going to simplify one last time. The distance equals the square root of 4 is equal to 2. The square root of 5 is a decimal, so I'm going to leave it in simplest form as the square root of 5. So our final answer is that the distance is 2 square roots of 5. Our last problem for today. Are the following segments congruent? Explain how you know. MN has endpoints M at 0, -4, and N at 5, 8. And segment ST has endpoints at point S at -1, 2, and point T at 11, 7. So we are going to need to do the distance formula twice. So I'm going to do MN over here, and I'm going to do ST on this side. So for MN, I'm going to label M as my X and my Y. I'm going to label N as my H and K. So our distance equals the square root of X minus H squared, and I'm filling in the numbers as I go, plus Y minus K squared. Now I'm going to show you a small little trick on your calculator that can help reduce your steps and reduce the chance of error when we're simplifying our radical. So I'm going to type in what's under the radical, not the square root itself, just this part right here underneath the radical, just as I see it on my paper. So look what I'm going to type. Parentheses, 0 minus 5, close the parentheses, squared, plus parentheses, -4 minus 8, close parentheses, squared. So not the square root, just everything underneath it. And if I push enter, that tells me 169. So I now know that the distance equals the square root of 169. What's the square root of 169? That would be 13. So we're halfway done. The distance between M and N is 13 units. So let's find the length of ST. The distance equals the square root of X. We're going to put X and Y for S and H and K for T. So it would be 8X minus H squared plus Y minus K squared. Again, we're going to use our calculator to help us out. Just type in this part under the radical, not the actual radical. So, parentheses, -1 minus 11 squared plus 2 minus 7 parentheses squared, and we get 169. So the distance equals the square root of 169, which means the distance is equal to 13. So, are these segments congruent? Yes, the distances are the same. To put things a little more mathematically, since MN equaled 13 and ST equals 13, we know that MN equals ST, so therefore segment MN is congruent to segment ST. And finally, for our summary, describe how the words distance and length can be used to ask the same question in two different ways. Also, what's a real-life situation where you would need to calculate distance? That's all for today. See you in class.